This screencast is on liquid crystals. Liquid crystals are an important part in modern technology and for most of us are a part of our daily lives without us even knowing about it. They are even being currently used in the screen you're looking at right now. But what are liquid crystals? Well, they are partly ordered materials somewhere between the solid and the liquid state. They usually possess a structure containing a central core, an unsaturated linkage, usually containing carbon-carbon or carbon-nitrogen, and the structure of the liquid crystals allows them to be manipulated using electrical forces, and this is what allows them to be used as LCDs. But how were they discovered? Well, they were first discovered by Austrian scientist Friedrich Reinitzer in 1888. He discovered that the molecule cholesterol benzoate had two melting points. At 145.5 degrees Celsius, it went from solid to turbid, and at 178 degrees Celsius, it went to liquid. Upon cooling, he discovered that the sequence had in fact reversed. Reinitzer concluded that he had discovered the liquid crystalline state. In 1960, Pierre-Gilles de Jean made developments in regards to magnetism and liquid crystals. This formed the basis of George Gray's work in 1973, where he discovered a type of liquid crystal that stabilized at room temperature, and this is what we use for LCDs today. What is the structure of the liquid crystals? Well, molecules are either disc-like or rod-like in nature. This allows them to be parallel to each other. Intermolecular forces are still present, however they are not the same in different directions, therefore they possess no positional order. There are two phases of liquid crystals, the first one being the symmetric phase. This phase is closest to the solid state due to the strength of the intermolecular forces that are still present. This means that the layers cannot move over each other. However, the most commonly used phase is the nematic phase. This is closest to the liquid phase, and molecules form twisted structures. Molecules in the nematic phase reflect visible light, which forms different bright colors. Different molecules have different spacing between them, and this causes different levels of diffraction, hence the color varies on the pitch. The level of diffraction is also affected by temperature, allowing for the use of liquid crystals in thermometers. But how do LCDs work? Well, the light is first shown through a polarizing filter, and this polarizes the light before being shined through the twisted nematic phase of liquid crystals. This twists the light The light is then put through a filter which changes the color that is displayed on the screen. However, if a force field is applied to the nematic phase, then no light will be produced and the screen will be black. What is next for liquid crystals? Well, NASA are currently studying liquid crystals in microgravity in order to understand the two-dimensional system physics of complex fluids. This is being conducted by a group called w6n66. The applications of this in space would mean that liquid crystals could be used here. This would make communication between astronauts and Earth much easier, and could even use video messages. What are the Earth applications? Well, it would improve these. Phones. This will allow us to create devices with improved color contrast and responsiveness.